The presentation you are about to hear is entitled Finch Cambridge, Truly Affordable Passive House. And it was originally scheduled as a session at our annual conference, Building Energy Boston. As you may have heard, we recently made the decision to make Building Energy Boston an entirely virtual event this year. This pre-conference webinar will give you a taste of what's to come when we run the full event, August 12th to 14th. In just a moment, you'll hear from Bev Craig from the Massachusetts Clean Energy Center, Michelle Apigian from Icon Architecture, James Peterson from Peterson Engineering, and Tom Chase from New Ecology. In just about a minute, I'll turn it over to them to introduce themselves, but before I do, I just want to say thank you. Bev, Michelle, James, and Tom, thank you for all the time and energy you have put into making this webinar happen, for your willingness to share your work with colleagues who want to learn about it. Before I do turn it over, I want to run through a couple of quick tech tips. First, although you don't have the power to speak in this webinar, we do want to hear from you, specifically your questions. So please use the Q&A function at the bottom of your screen to submit questions. We'll be keeping an eye on them throughout the presentation and setting aside time at the end to discuss. Second tech tip, we recommend that you select Fit to Window and Side by Side under the view options at the top of your screen for the best viewing experience. So, thank you for joining us. Ask questions, tell us what you think, and enjoy the webinar. With that, I'll turn it over to today's speakers.
Hi everyone, I'm Beverly Craig with the Massachusetts Clean Energy Center, and I've gotten really good in this new normal at culling everything out of my refrigerator to cook vegetarian new meals that I've never tried before.
Awesome, thanks Bev. I'm Michelle Apigian with Icon Architecture, and I have been punch listing closed job sites in large buildings that are completely empty or nearly empty, and it has been a very strange feeling, and for some period of time without power.
You've been, oops. Can you hear me now, Michelle? Great. Okay, James Peterson, Peterson Engineering. Perhaps you've been cleaning out your closets. I want to show you something I found this morning in my basement. Just a moment. This is image of, let's see here, me, and this is my pal Vladimir Putin, and we're on horseback. And I know it may look doctored, but I swear it's not. I think he may have been showing me the recently annexed part of Ukraine, Crimea. But anyway, it's found it in my basement this morning.
Thanks, James. And hi, everybody. I'm Tom Chase from New Ecology. And I've observed that one byproduct of flattening the curve has been flattening the distance. I'm speaking a lot more with family and friends all over the world, which is a silver lining.
So just so that everyone knows, this webinar is being recorded and it will be available on the NESI website. And so all of our contact information, if you want to follow up with any of us, will be part of that recording and the slides that are available. So just as some context, here in Massachusetts, we have seen a dramatic amount of momentum building around passive house. So right now there's only one building that's multifamily in the state that is certified passive, the one you see here in the South End, the distillery, but that is changing fast. The Massachusetts Clean Energy Center, where I work, created a program to provide $4,000 incentive per unit incentives for affordable housing to go to passive house levels. And we awarded 8 of those. And then 9 months later, we saw the Mass Save program launch a very similar program, but for both market rate and affordable for $3,000 per unit incentive. In addition, the low-income tax credit program in Massachusetts has pretty recently created a reward around passive house compared to LEED buildings or enterprise green communities buildings. And the Department of Energy Resources at the state, for large projects that are triggering the environmental impact statements, they've been encouraging passive house for quite a while. And so all of this is leading to huge momentum. So just under this Mass Save program, right now they've already in 9 months signed up over 3,500 housing units for buildings looking into passive house. Now they may not all certify, but it's really encouraging to see that. And they've been all over the state. They tended on average to be about 75 units, so we're talking about fairly large buildings. And just so that people know, this incentive is out there right now. Any multifamily building over 5 units can get 100% of a feasibility study to study passive house, 75% of energy modeling costs up to $20,000 with some limits around unit size. And then if you actually do certify, it's $3,000 per unit. 500 of that comes at pre-certification and 2,500 at the actual certification at the end. And so what everyone wants to know is, how expensive is this? And so it's really cool because this is going to be the next building that's certified in the state. It is an affordable project. Michelle will tell you a whole lot more about it. But on the cost side, we have just gotten the final costs. And first I want to preface this by saying, this is not your typical building, the base building that they came in with in the state. So it's in Cambridge, which of course is pushing for net zero, and obviously they're asking for a lot out of new construction. And I think Michelle, because of her past history with passive house, came in with almost a stealth passive building, some shading features, and I think a lot more continuous exterior insulation than you typically see, at least in a non-stretch code community for sure. But the great news is this building only 1.4% increased in costs. And that is both soft costs and hard costs, and it's not netting out any incentives that they got. So it's just the real thing. And anybody interested in the details here can give me, send me an email and I'll send it to you. But in terms of what did cost more, upgrades to ventilation and the ERV system was probably the biggest one. When they started this, stretch code was not requiring fresh air to every bedroom. And so making that change was the biggest cost for the project. Also higher costs for the consultant as compared to a passive house consultant as compared to a normal one, and increased insulation and thermal bridge breaks, upgrading to triple glazed windows, and the passive house rater. So those are the main things. One thing I will share is that ventilation change, actually after, we're in the concurrence period for the code upgrade right now, and after August, I think that'll be much less of a factor, because even just for stretch code, you'll need to meet a lot of the standards for ventilation that are required in passive house. So I would say this is a low cost. I would say you wouldn't typically see this, but some base buildings that have a high starting point. So for example, a Boston proposed project, a Cambridge, or even Newton, where you have to hit LEED certifiable, you might be seeing in this range, or maybe a slightly higher. I'm going to hand it over to Michelle.
Awesome. Thanks, Beverly. I'm going to make sure I've got control. Hold on. I don't. One moment. Okay. You've seen this image. This is the rendering that has been out there for a long, long time, that we presented to the city of Cambridge, I think 2.5 or 3 years ago now. This is what it looks like today and has looked like for the last 2 months. We were 6 weeks away from turning these units over to 98 families, and when the job got closed down for construction. So it's so close, and the great news is that we just got the go-ahead that we're going to be able to start construction on Monday, and we should be occupying in July. So we're super excited. In Cambridge, and frankly in our current climate change driven situation, we need to be thinking about way more than just energy. We need to be thinking about resiliency and health in so many ways. And so this is a project that definitely thought about flooding. In this particular case, we're across the street from Fresh Pond. We definitely will experience at times flood surges. Oh, I lost control. There we go. So our sort of overall party, not unusual here, but we kind of lifted the residential units up above a parking garage as well as the main entrance lobby level, so that they are always and forever, we would hope, well above anything that could possibly create flooding damage, which of course is so dangerous. But even our lobby is above the 2070 storm. And here's how it's sort of panning out in terms of what our WWOOFy modeling is suggesting. And of course, this is an evolving thing as we are working through construction and continuing to check back with FIAS. But overall, it's looking like our site and source energy are going to both be less than half of what a kind of conventional building of this type multifamily would be, which is exciting. And so what I really want to focus on for the next few minutes here, oh geez, hold on, I don't know why I don't feel like I'm driving, is how do we get these buildings built? Because it really isn't just about design. It's not a wave a magic wand. It really takes execution in the end. And that's kind of one of the beauties of Passive House, is that our builder needs to be our partner, and we can really think about the craft of building, which has long been kind of an afterthought in our construction in the States. So these are the 4 words that have come to embody my current notion around this: communication, humility, appreciation, and mentorship. We, as Beverly mentioned, the distillery is the first multifamily project in the state and still only completed at the moment. It was completed in 2017, and Finch Cambridge is our second and nearing completion. And we've got a third underway in Gloucester that started at the beginning of the year. And so at each stage, we've had the opportunity to learn and try to think about how to make this process more streamlined and seamless. And communication is everything. So when we got to Finch, we thought, well, the first thing we need to do is throw up some important signage so everyone understands what's going on. This is an airtight building. I don't know that that made a big difference. Maybe it did. It made me feel better. But it was sort of our first thought about how do we communicate differently with the folks on site. We also spent a lot of time in our drawings talking about air barrier, thermal envelope, what's in, what's outside the Passive House, and doing that in color, so that, and asking our builder to print things in color so that it was easier to understand what we were talking about. We did this not just in plan, but we did this in section and in details, with a whole lot of detail as we developed along, in this case, extremely explicit about about what product, what each color meant, to help them along. And during the design phase, but then again during construction, we needed to keep going back to other modeling and other tools to verify some of our assumptions, using therm to help us understand, in particular, thermal bridging issues. Again, that continued during construction because we needed to make sure that some of our assumptions were still panning out. And this process we shared with our contractor. This was not happening sort of on the sidelines. This was happening with them so that we could collectively come up with the best strategy to get what we needed. But at the end of the day, a drawing set can only communicate so much, and so can specifications. So we ultimately were finding that some things are just too complicated to understand until you see them in 3 dimensions and can look at them together. And we began taking photographs of physical things that we had actually detailed in the sets, but are now built on the site. And we would then kind of draft over them to try to articulate the sequence and make sure everyone knew how to get done what we knew we needed to get done. We spent a huge amount of time, as anyone will on a Passive House building, focused on airtightness of the envelope. And we worked hard to help support Kaio and his team. This is the foreman for the carpenter who was doing all of the air barrier work on the building. And they just did a phenomenal job. And it didn't happen by accident. It happened because we let them know that their skills are valued and that they're really important, and we're going to have our eyes on them. We're going to let them do a mock-up and make sure we think through, is that working for you? Does that feel like you can do that 5,000 times across the building? Because a flat facade is not so hard to envision doing successfully, particularly with a good product. But corners, transitions, windows are very complicated. I want to pivot for a minute to talk about the project we're now working on in Gloucester, under construction since January. This is 30 units of affordable housing for the North Shore CDC, and it's supposed to be complete by mid next year. It's been the next opportunity for us to iterate on how we communicate as a team. And I want to just kind of talk through what that has meant to us. There's a lot of slides here, and I'm going to kind of fly through them, but I want to start with the language that a contractor speaks, which is the 3-week look ahead. They don't speak the passive house language necessarily, and they don't necessarily need to be able to say adiabatic or any other exciting word that we like to get into. That might just be frightening and confusing, but what they do know is what's coming every few weeks out in schedule. And we began to embrace their approach to communication and think about how we could be proactive within this process. And so we started to identify, well, what's coming up in your 3-week look ahead? Stair 2 is the first thing out of the ground that's going to matter to us from a passive house perspective. Stair 2 is a tiny little gem, more complicated than I wish it were, inside the passive house envelope and surrounded by non-passive house envelope spaces, including the exterior and interior. So very complicated. And we had a whole lot in the set around this, but we instead thought, instead of waiting for it to be built on site, let's develop a 3D axon of this particular location, and let's send it to the contractor, ask them which trades would need to be involved in this sequence of events, get them on a call for an hour, and talk through the process. And so I'm going to very quickly show you what that looked like. We literally just in Bluebeam over an axon that we developed in Revit, explained what's happening in our minds first, second, and third. And then what happens next, and then what happens next. And those yellow spots are really important transitions that often get fussy and difficult. And we, of course, we're always reflecting back to the details that we had in our set. This wasn't coming out of left field. These had been defined in plan and section. And then we would move on to the next detail. And what we have found invariably, we do one of these calls every other week, every few weeks when it's necessary. It's a standing time, takes an hour. They get the right foreman on the phone, and invariably we find that one of our details doesn't work, or the way we thought it was going to be sequenced is not accurate. That just doesn't, it can't work that way. And then we have an opportunity to address that in advance of anything getting placed, so that we don't have to have headaches and figure out countermeasures. So this was the next phase, and this particular sequence is way more complicated. And then we thought, it'd be helpful, contractor, if you would start to think similarly. Tell us what's coming visually, so that we can even be more proactive about what we need to talk about when. And so here we are, they're talking, so the next sequence. And it's been an extraordinarily productive and frankly fairly simple process, and they all get it. And we don't talk a huge amount about passive house. We just talk about sequence and the detail and who's doing what when. And now I come back to why that's so important, because it turns out the air barrier on the exterior walls is not the only thing that we have to be concerned about from continuity perspective. There are lots of other trades depending on what's happening. And this, here we have our plumbing foreman. He's out there. We have it in mock-up on the left here, what it's going to look like. Here we're back at Finch, when penetrations come up through our unconditioned garage into our first floor residential space. The first attempt didn't look so great, and then it got wet and it really fell apart quickly. But the second attempt, knocking it out of the park, and from then on, we never had to look back. Similarly, the folks, Eric and his team, are installing all of the ERV ductwork. It's a central system. There's a lot of ductwork. If it's leaky, in little ways, it's going to add up to big problems. So we wanted to, he knew his job was important. We let him know what he's doing is valued. And we had kind of a regular testing schedule and phases. And it was highly productive, and we haven't had it tested full building yet, but it's coming soon. And then, of course, it's not just, unfortunately, the communication has to be carried on during a long period of time. So we did a mock-up, months and months and months ago. It looked fabulous. Boy, did they get that right. And then the electrician came on the field 9 months later to begin installing outlets in our exterior wall. And OMG, was that unexpected. So we had to sort of nip that in the bud. Similarly, we've got raters, verifiers, New Ecology on our team to help do some evaluation of how just general installation is working. Are we getting it right? Checking that early on so that the overall we're not having endemic problems. Here's the insulation folks who suddenly become very important, because here actually our foam, spray foam, which I don't love to use, but is also being used as an air barrier. And so they actually factor in as well. And here we are. Now it looks almost like the last slide I showed a few minutes ago, but this one is on a demising wall where the electrician didn't get the memo that compartmentalization matters on the inside too, and they have big thumbs, and it's very convenient to cut a big hole. So, if you catch this early, you can solve the problem and address it going forward. And finally, I just want to say it's a huge team. It takes a team. And that's really what I've come to really love as much as anything about the Passive House movement, is that it's partnership, it's collaboration, it's working together to solve problems. And frankly, not only do we get better outcomes, but we have a lot more fun in the process. And, now I can't seem to, okay, hold on. I'm trying to transfer this back to somebody. Wow, what just happened? Did someone steal it from me?
I may have, Michelle.
Okay. Oh, maybe that's what happened. Perfect. Thanks, James. And I will.
Let's see if there we go. Thank you very much, Michelle. So I'm sure, I know coronavirus is on everyone's mind, and we've been getting a tremendous amount of inquiries about how ventilation in buildings can help or hurt relative to COVID-19. And so I'm going to focus my time on ventilation systems. So there's 3 general approaches for ventilation in a passive house multifamily project. And I'm going to spend a few minutes here just defining terms. Local, and basically all 3 of these refer to where the ventilation equipment is located. Essentially, the duct, for all 3 of these systems, the ductwork extends to all the same places. Exhaust from bathrooms and kitchens, and fresh air to living spaces, living areas and bedrooms. So the local approach refers to the equipment being in each individual dwelling unit. The 4x4 is, I'll get into them. Let me go back one. So 4x4, the equipment's located on 4 plates, and it's supplying a certain amount of the 4 plate. There might be multiple units per floor, but we're not going vertical with ductwork. We're staying in the 4-plate plane, a single 4-plate plane. And then central is what Finch has, which are rooftop units, packaged rooftop units. Sometimes we call them DOAS, dedicated outside air systems. All of these incorporate ERVs, not as many HRVs anymore. So we get a little bit more into defining what each type is. So here's a schematic representation of an ERV. It's showing it local in an apartment. Ideally, it's on an outside wall. There's penetrations to the outdoors. It's each apartment has its unique ventilation system. Here's a representative piece of equipment. They can be a little bulkier as they get more efficient. So I wanted to give you a sense of scale. These require a closet. So that's local. So moving on to 4x4, we show a piece of equipment. We have to find a mechanical room for it. It has to be ideally close to an exterior wall. It's hard to come by. This requires early planning, and it serves multiple units. And it might serve a dozen dwelling units per piece of equipment. Here's an image of one. This looks like a large fan coil. Oops, sorry about that. Skipped ahead sooner than I thought. This is central equipment. It varies in scale depending on how many thousands of CFM you're dealing with, and the ductwork is extending to dwelling units, and you could have dozens of units on a single rooftop unit. Let's see here. All right, and there's it pretty much looks like a piece of rooftop HVAC equipment. And then on the right is a damper. Because the ductwork is quite extensive, it's difficult to balance. It's critical to have sealed ductwork, and that's a consideration. And we'll get into more considerations for these three types of ventilation approaches. They all incorporate heat recovery or energy recovery. So this is a kind of a energy recovery 101. Basically what you're doing is you have the exhaust air stream in proximity to the fresh air stream, and they're meeting at a heat exchanger. And by the miracle of modern science, they're exchanging heat and moisture at the heat exchanger, but they're not recirculating air. And we'll talk a little bit more about that. The two connections on the left tend to be colder air in the winter because it's fresh air from outside, and the more efficient the unit is, the colder that stale air exhaust is to the outdoors. And you're exchanging, again, heat and moisture. This is an illustration of modeling the three approaches. And the point of this slide is to say that whether it's local, which in this slide is called decentralized, sorry to mix terms, or if it's semi-decentralized, which we're defined as 4x4, or it's central, we're in the same ballpark, probably within the margin of error of being hard to say which one's better in terms of energy. In terms of cost, it's the same thing. There's no clear winner. It's in terms of cost, it kind of depends on who you talk to in terms of the estimator. Might be specific to the project type. So with costs and efficiency differences, what are the other considerations for the three approaches? So with local ventilation, and I think with COVID-19, we might see some more interest in local ventilation. As long as you have a very well compartmentalized apartment, it has the appeal of having your ventilation unit that's just yours and is not shared with anyone else. And when we get into the other two types of equipment, we'll talk a little bit about the issue of cross-contamination. And I won't go through each consideration. You can read yourself, but I'll just highlight a few. There's minimal amount of ductwork, which is very nice, and therefore balancing is easier. And the cost should be lower in terms of the sheet metal costs. You do have more pieces of equipment. So in this case, you have a piece of equipment associated with ventilation for each apartment. And an example of that being onerous is that it's another piece of equipment that has to be serviced if you compare that with a central system. The Finch job, for example, had 2 dedicated outside air systems on the roof. And if you go this route, you have many pieces of mechanical equipment. And then in this case, we're not able to mechanically dehumidify the air with this approach. And that's unfortunate, and it's a shortcoming of local ventilation. With 4x4 ventilation, a big plus is that we're not going vertically in the building. Therefore, we're eliminating the need for some shafts, which helps us with our interest in compartmentalizing the building. It also reduces the complexity of the building. No fire smoke dampers, which helps reduce and control costs, and less construction associated with shaft work. One of the difficult things, and I touched on it earlier, is early planning is required in order to find a home for mechanical space on the floor plate. And oftentimes it's the highest quality floor area. It's on an outside wall. If it's a double-loaded corridor, you might be trying to find a mechanical room at the end of the corridor, but that's cutting into possible dwelling unit space. So that's a difficulty with this approach. Another difficulty is there's less manufacturers on the market now at the moment making products that we can choose from. So it makes it harder to feel confident about cost control. And then also there's a narrow band of choices in terms of how many units move, say 200 CFM or 1200 or 1000 CFM, and not many choices in between. So we need more availability of choices. The central ventilation system has the most, the market is the most mature in terms of choices. There is this slight, very small percentage of cross-contamination that you're not going to get away from when you bring ducts into near each other and across a heat exchanger. And so that's where I think we have to do some education and educating ourselves, and then helping others understand what those risks are and how they compare with other risks in terms of spreading bacteria and viruses and other harmful things. So central, like I said, is it's commercial grade equipment. It's a very mature market. Another thing is, as we're looking into things like clean air, like ionization and UV, those are accessories for this type of equipment. So we have a lot of control. We can go to HEPA level of filtration if that's appropriate. And that makes this very, very desirable in terms of COVID-19. Complex duct system is a major issue. Basically requires a retraining of everybody down the line to get the ductwork sealed, to get the ductwork balanced properly, and it's a major drawback and big hurdle to overcome to have a successful job. And then again, like the 4x4, it's going to have this inherent risk of cross-contamination at a very slight, and when I say slight, it could be as low as 0.1% of total airflow, as high as 3%. But the important thing to point out is that these are 100% outside air units, as opposed to recirculating equipment, which is the most common type of air system in buildings, all types of commercial buildings specifically. So these are all three 100% outside air approaches to ventilation. So that's I've gone over a little bit on my 10 minutes. It's time for me to hand it over to Tom. And this is just a summary of the things we just talked about.
Great. Thanks, James, and thanks, Michelle. So I'm going to talk about the role of passive house verification in the certification process, and then go into some of the specifics of the verification that we're doing in partnership with John Rodenheiser at JSR Adaptive Solutions at the Finch project. So pulling up the slide that Michelle had before and echoing in the comments about this really being a team effort, the passive house verifier or rater on smaller projects is really a third-party role. So we think of that often as a good cop, bad cop situation, where our goal is to get the building to perform as designed and to perform as well as it can. But we also have to faithfully report our testing results to the certification body. So that's where communication early, often throughout the process, is really key. The way we get there is with the contractor, with the design team. We communicate what's being tested, how it's being tested, and what it takes to pass. So some of those tests that folks have probably heard before, the big ones are the whole building lower door test, compartmentalization, air barrier tests, domestic hot water temperature rise tests. I'm going to go into a couple of those that we've done. We were scheduled to do the whole building blower door test just about the second week of March. So we're gearing up again now to do that, as we're going to be back on site starting next week. So again, looking at the compartmentalization drawings that Michelle showed, some things to notice about these. It's important to have both in diagram and overview, as in this drawing, as well as in detail, those tricky details at corridors, at door frames, at truss connections. These are in color. I think this should be the norm, and it's not necessarily, but it really helps get across the point that we are not just building a tight air barrier at the outside of the building. We're also compartmentalizing units so that mechanical systems are serving the spaces they were designed to serve, so that pests and odors are controlled between units, and we're hitting both performance and health and indoor air quality targets. So for folks not familiar with compartmentalization testing, here's Zach from our office installing a blower door, just like you would use at the outside for a single family home, but in the corridor at the entryway to the unit, and some of our preliminary test results. I wanted to highlight what those test results look like, because apartments are small, and the smaller your surface area, the harder it is to hit an air barrier test result. Small leaks have a bigger impact in a small surface area. So if you look down at the bottom of the chart here, we're passing with this unit by a healthy margin, and the passive house standard of 0.3 CFM 50 per square foot of unit enclosure translates in our test result here to about 4.5 ACH 50, which for folks who are used to the 3 ACH 50 requirement in single family whole building tests, that may sound high. This number is about where LEED was in its previous version. It's a little bit higher than where LEED is now for folks familiar with that standard. But here at Finch, this is one of the first units we tested. We're passing comfortably. And most of the leakage demonstrated actually is to those tricky details at the corridor, at demising walls, and not to the exterior where that primary air barrier is located. So one of the things we do with our compartmentalization testing plan is that we always do a mock-up unit as soon as a compartment is complete. So as soon as we have a unit ready to go, we do an air barrier compartmentalization test to demonstrate where our concerns are and what we can do as we move through the unit. So we look at things like windows down in the lower left and right. And in the center and up to the top, we look at things like light fixtures, the frames around doors at corridors. So we can call out where we did air sealing well in the unit and where we need to do a little bit more work with the team to get these units tight. Here's some closer images on the left, that door frame at the corridor, and then a light fixture and a sprinkler head in the center and the right, demonstrating some minimal air leakage. Again, this was a passing unit, but there's always, there's always room to have a slight improvement in the air barrier. We also do duct testing. So the duct testing that Michelle was talking about before, talking about the central ventilation system duct testing. For FIAS in particular, that testing could be owned by the rater verifier or by an independent testing entity, which can be a sub to the HVAC contractor. There's also the in-unit duct tightness testing, and that's a passive house requirement, that's an Energy Star requirement, and that has a slightly different standard as well. This was a really exemplary project. We find that duct testing reveals a whole lot of surprises down the line, and in a place that you don't necessarily want to see them. Peterson Engineering does great details around duct tightness testing in their drawings. We had a contractor on this team that really understood those and carried them through. And we passed every duct tightness test on the first try, which was really remarkable, especially when we have things like leaky boxes, leaky fan coil units from the manufacturer. Those were all sealed up and made our job easy here. Another thing we're doing for FIAS verification is thermal imaging. So we're doing thermal imaging, ideally with good temperature differential, indoor to outdoor. So when we're heating the building or we're cooling the building, ideally also when we're depressurizing or pressurizing the building during a whole building blower door test to find out where those thermal bridges are. We try to design them all out, but nothing ends up getting built exactly as we draw it. And so part of the role of the rater verifier is to help catch those changes, those realities on site, and figure out how to deal with them so that it doesn't throw us off our certification, so that we don't have unexpected issues down the road. So on the upper left, we have it's actually an anchor for a fall arrest tie down. So we have this on the roof so that when folks are working on the solar panels, they're up on the roof, they can be safely secured. And it means that we don't need to build a barricade at the roof edge or a high parapet. But what we do have there then is long steel bolts coming through the roof assembly. We demonstrated there's a little bit of a thermal bridge there, and added some additional spray foam at the underside of the roof to amend that. We also do thermal imaging of the exterior, and this is a really interesting photo. I don't want to go into all the details of the thermography job and the art and the science of reading these images, but basically what we're demonstrating here is that the air barrier and the continuous insulation are performing as expected. On a large building, on very large buildings, the air barrier is responsible for most of the thermal control. And the insulation, the continuous insulation outboard of that is what's needed to get you over the hurdle to a really exceptional performing building under the passive house standards. So what we see here is that most of the work is being done by the air barrier. It's not showing leaks. The building is being temporarily heated in these images. And the continuous insulation outboard is doing its job as well. These are some earlier images from inside the building, and these aren't really what I would call verification images. They're kind of quick snapshots, but they're really useful, and were really useful in the conversation earlier, maybe halfway through the construction process with the contractor about why we're doing what we're doing and how that impacts our performance. So on the left, we have a unit that does not yet have continuous insulation. The variation across the whole thermal image is not terribly high, but what we do see is that we see framing. We see framing at the windows, at the vertical framing members, and that's some thermal transfer that's happening between the indoors and the outdoors. Going into a unit on the right that already has this continuous insulation, there's almost no thermal transfer happening there. And this image just really quickly got across the point that we're doing a really good job with the exterior insulation, and we're doing that because it drives performance like this. So I think we want to pause here for a quick poll while I wrap up the testing section, just to see what folks took away from that. Thanks. So here the question is, true or false, all thermal bridges are identified during design, and no testing or verification is needed to update design phase energy modeling. So the question here is, what do you do when you have a thermal bridge in your building in construction? You have to add it into your energy model and see how it impacts performance. And I think, judging by the majority of responses here, folks folks for paying attention. All right. Thank you. So my last few minutes, I want to switch gears a little bit and talk about a few other pretty cool features of the Finch project. So at Finch, we have a very large roof, and we're able to largely cover the roof in a solar PV system. So this is about 105 kilowatt, 105 kilowatt DC system. And simple payback with all the incentives that we have in Massachusetts currently at a little under 8 years. This is a great way for passive house projects to get below their source energy requirement. So producing renewable energy on site really helps with the source energy requirement. This is a big building, it's densely occupied, so we won't offset half or nearly that of our electricity use on site, but it does make a big difference. And it's on the owner's meter, as are most of the heating and ventilation loads as well. New Ecology is also doing a monitoring and optimization scope. So after construction, we want to make sure that the building still performs as expected, that we can identify any issues that need to be corrected in the operation of the building to make sure that we get our energy performance. So as of right now, we'll be monitoring the VRF energy usage, both the exterior units and indoor set points and temperatures. We'll have a central water meter that we're reading hourly, so much better than the quarterly billing that we get from the city. We'll also be monitoring the domestic hot water usage, both the gas usage at the boiler and the electricity usage at the pumps, as well as the water usage for hot water, where we have a recirculating hot water system here. So we'll be able to measure exactly how much water is coming out of the taps instantaneously throughout the year. We're also measuring energy usage at the domestic hot water recirculation temp and electronic tempering valve to get a sense of how the hot water system is performing and make any adjustments we need to. Let's see, I think I have a diagram. Yeah, so here's a diagram of that domestic hot water monitoring with just the water usage meter there. It's a pretty simple piece of equipment. It goes in on the makeup feeds of the domestic hot water system, but it gives us information that we don't typically have for a multifamily building. So we're really excited to see what comes out of this. And I think with that, we want to wrap it up and go into Q&A.
Am I muted still?
Good.
No, I'm okay. First question is sort of a housekeeping one. I think Miriam's actually going to have to answer this one, which is CEUs. People are asking about CEUs and in particular FIAS, if these have been approved for a FIAS hour.
Yes, they have, and we'll be sending out certifications and information about getting your CEUs after the event.
And then there was a question for Michelle about the training of the contractors and whether they are passive house builders or what kind of training they've had, and of the installers.
Right, so generally speaking, the answer is no. And that's going to be the case for, I think, a while until we have more of these projects built. During the construction, a couple of the folks on the GC side did do training, builder training. No, actually, they didn't do builder training. So they did the CPHC training, the Certified Passive House Consultant, because that was what happened to be available. And I joked earlier about what do they need to know? What do they want to say? Do they need to know adiabatic? But actually now our PM and the folks, the Ben Coulihan, who's actually doing the estimating in the office, which is critically important to getting these projects coming in at the right cost, are both able to use that term. So it definitely makes a difference, but it's not necessary. I think we can help lead the way when that is not an option. And for the moment, I think that's where we're going to be for a while.
And then there's some questions about the cost for the testing and verification and how that compares. And I know a little bit about this. So the overall numbers, when we said there was a 1.4% increase, that split out on the soft cost side, which included the testing and verification compared to what the base building was going to have to do. It was a 2.2% increase. So Tom, you might be able to elaborate a little bit more.
Yeah, I think that number that you just gave there is pretty similar, Bev. It's again a condition where the baseline is not that low to begin with. You know, we have Energy Star certification on most buildings that we're doing in this region. We often have LEED certification. So if we're doing Passive House instead, it's a pretty similar scale and then a slight increase for that testing and verification.
And then a general question about what do all the panelists think is the most important factor in a successful passive house project? Ooh.
Air tightness.
Definitely air tightness, but I echo that, and I would add teamwork. It doesn't happen without everyone rowing in the same direction.
Yeah, I would be hard pressed to find two better than air tightness and teamwork.
So a question about the software that was used for the EUI calculations and energy loads.
So we're using Woofy Passive. This is a FIAS project, so that's where we get our EUI numbers from.
And I saw a number of questions that definitely indicated some confusion about ventilation and ERVs, so I lived in Cambridge in a 50-unit building that was probably 90 years old. And the amount of air transmission to my next door neighbor, I could smell their cooking and when they smoked all the time. How does that compare to ERV? And I think just like generally the way James explained sort of an ERV 101, but sort of the way I tend to explain it is like in my home in the winter, there's warm air and it gets exhausted. Right now that's all wasted when it gets exhausted. And an ERV puts in a heat exchanger to capture 80 to 90% of that heat and then preheat the fresh air that's coming in to ventilate. So I think people have this thought that ERVs and central ventilation is like mixing everybody's air, which is not true. It's central the same way. I think, James, you talked about like a sewer system is central from each home because we all go into the same sewer system. It's the same idea with ventilation systems that are central. That doesn't mean there's no ever risk of cross-contamination, right, James? But in terms of like a 100-year-old building with no compartmentalization versus an ERV, what do you think risk looks like for air transmission unit to unit?
Well, hopefully we're, not comparing that comparison. Let's see here. So if I think about the passive house building for starters, in an ERV or HRV, there's going to be some small risk of cross-contamination. And I think I don't want to hide from that. I think because I think it's going to be a concern that people want to drill down and understand what the risk is associated with that. And I think when you sum up all your risks, so let me just drill down on that a little bit more. So if you're at 98 or 99% effectiveness in terms of not having cross-contamination, so you're getting close to 100% outside air. One thing with the virus currently is they don't know what amount of dose is required for the virus to make you sick. And then you're going to have to draw quite a bit of virus from a lot of different apartments in order to have a dose of significance. And then when you run it out through your energy recovery ventilator, 98 or 99% of that exhaust air is going to head outdoors, and only 0.1, I said, to 3% is going to maybe cross-contaminate. So there's a tremendous dilution that's occurring there. You pointed out some other risks, which is dwelling units communicating with each other, or communication between corridors and dwelling units. Those are also risks. So what we have to do ultimately is assess all the risks, what helps us, what hurts us. For example, is a local unit without dehumidification capability, does that represent more of a risk than a central unit that has great dehumidification capability? So there's just a lot of risks for us to get to understand better and to help people assess the safest solution.
And James, sort of a related question was about what's the difference between HRV, ERV, and is dehumidification on the floor-by-floor ventilation systems possible? And then somebody mentioned Minitair as dehumidifying on a local basis if you go with that kind of unit.
Oh boy, 3 in 1. So an ERV basically, and this is it's like magic. Not only does it transfer heat from the exhaust air stream to the fresh air stream, there's a transfer of moisture across the medium, and that's. And I saw there was a question too about why preference for ERV over HRV, and I'll just answer that very quickly because it's a great question. And so in the summer we have a tremendous amount of humidity. It's our largest source, and by use of an ERV, we knock out that humidity dramatically with the ERV, where the HRV we wouldn't knock out any of that humidity. So someone may say, well, what about removing moisture in the winter? Well, with the passive house, in our assessment, we're not having an over humidification issue in the winter, so it's okay that the ERV is preserving some of that moisture and putting it back into the supply. The Minitair, we reviewed that, our office reviewed that several years ago, and we haven't, so I'm vague on that specific piece of equipment, but something we want to revisit, but I don't have any expertise on that to share with you right now. And there was a question right there in the middle that you had, and I forgot what it was. Maybe we don't know the time.
Dehumidification for floor-by-floor systems.
Yes. So back to the point of there not being enough equipment in that option. We have a design right now where we've had to kind of plug on a cooling coil onto the unit with the help of the manufacturer, but then it gets integrated with the VRF system, and simple is always better, and that one doesn't pass the simple test as much as we'd like it to. So we'd like to see that technology mature and be packaged by a manufacturer and provided to us on a platter.
Question about domestic hot water. What's being used?
On this project, it's set at central gas. This design, I think Michelle started in 2016. And this, so the drive for electrification, which we could talk another hour about, hadn't started yet, but that's a system. So central gas fired with recirculation.
Somebody was asking about where they can get more information like this. And I would say Passive House Massachusetts website has a lot of wonderful recordings that Mass Save has sponsored. Definitely recommend looking there. And I think we didn't get to all the questions, but I think there's usually a follow-up with the ones we weren't able to answer online. So look for those follow-up spreadsheets.
Hi again, Miriam here from Nessie. I just want to say thanks again to all of you for joining us today, and to Bev, Michelle, James, and Tom. We will be sending up a follow-up email, as Bev mentioned, to everyone who attended. And we'll be asking for your feedback and your ideas about how we can continue to be a resource for remotely. So please don't be shy about telling us what you think. Be well, everyone. Keep an eye out for more opportunities to connect with and learn from each other remotely in the near future.
Thanks, everyone.
Thank you.
Bye.
Thanks, Bella.